so why is my okay? Good. Let me get rid of here. Make it bigger. Okay, so I'm just gonna go crash course through this. I did this. Um, so you can check the answer. The answer is CA. I'm just gonna go through them all. Let's go. And
wait, why is 2A?
we're gonna talk about it. Yeah, 2 is A. Okay, so we're just gonna go speed run through this because okay, so I want to talk about something. Yesterday I watched so I kind of wish I can show you that clip of yesterday. I spent a lot of time watching TikTok recently, and I just thought like I watched like Kobe Bryant, and I kind of miss him because he passed away. So it's a mess. What I'm trying to say is Kobe Bryant. I saw this one clip, which is I never seen before. He went to Notre Dame basketball. He watched the finals, and the Notre Dame girls lost. And the starting player was one of the best player at the time, and so he talked to her like 3 months later, and he's like, hey, how you doing? And you lost that finals game, but congratulations, you did very well. But probably that's not what he said, because knowing Kobe Bryant, that's not how he said. But Kobe Bryant's like went up to her to say, hey, have you ever watched that championship game? And she's like, no, I never watched that game because it hurt so much. I don't want to remind myself. He's like, no, let's watch together. So Kobe Bryant sit down with her and watch over that game over again. Um, and so he told her, he's like, you have to watch this game. He said the reason why you have to be able to face your own mistake. When you make mistake, you have to go find out where you make mistake. So he forced her to watch the whole game with her. So I think that video have really, really a lot of respect for Kobe Bryant, because that proves like he's really he's a people know him as a jackass. Like I don't know if you ever seen have you seen him do you ever see Matt? You probably see that commercial with him with the 81. Uh, yeah, he scored 81 point on this basketball player, and this basketball player saw him in the bar, and he's like, "Hey, Kobe Bryant," and he's like, he didn't want to see him, but he said hi, Kobe Bryant, and I forgot his name. He's a ESPN guy, um, and then he saw him, and he's like, "Yeah, I want to order a martinis," and it's like they asked him how many martinis you want to order. He's like 81 ounces, and because he scored 81 point on him, and but people always know like he's a very he's just he's a very jackass, but he's not actually. He will sit down with a female basketball player, and he will sit down with them, and he will say, what kind of mistake you make. He'll go through the whole mistake, and he said the biggest problem of people is always afraid to see their own mistakes. When you see your own mistake, you're not correcting it. So he forced her to watch it, and but I thought that was a very good teaching moment of the person. That actually proved that Kobe Bryant is actually a very, very nice person, instead of he's as known as a jackass, but he's not. So I thought that's very, very important. When I saw that clip, I had like a lot of respect for him. But anyway, so go back and look at your mistakes, right? So that's something that you do. A lot of you guys still didn't come on the related rate. I know Edison did, but please come back and then make sure that you find out where you made mistake on. So I'm gonna speed run through this, and if you have misunderstanding, just let me know. Please don't be afraid to ask question. I think a lot of you guys are afraid to ask question. So if I take a derivative of this, and you have to take a derivative correctly, will be 2 sine of x cosine of x. And I'm going to rewrite that because this is sine of 2x. Not just because of double angle identity. I can take a second derivative. So that's be 2 cosine of 2x. And I'm set that equal to 0. So it'll be 2 cosine of 2x. I'm going to finish it before I answer your question. So 0 equal to cosine of 2x. Now you're going to figure out when the cosine equal to 0, which is cosine equal to 0 at pi over 2 and 3 pi over 2. And then you're going to divide it by 2, so it'll be x equal to pi over 4 and x equal to 3 pi over 4. So this is true answer. Now, for me, that I will be secure to make sure I do a number line test, just because I don't know if that's actually a change. Now, how do I plug in? I will plug in, let's say, something less than pi over 4, which is pi over 6. If I plug in pi over 6 here, then it's going to be pi over 3, cosine of pi over 3. Cosine of pi over 3 is first quadrant, so it's going to be positive. And I will plug in something like pi over 2. If I plug in pi over 2, it would be cosine of pi over 2 times 2 would be cosine of pi. Cosine of pi is going to be negative. And cosine of, let's say, it's 2 pi is going to be positive. Okay, Devin, you can answer your question now.
So if you don't have a double identity, how would you find the derivative of 2 sine x cosine x?
You're going to use a product, you're going to use product rule, but you still have to use double angle identity at the end because you're going to get cosine square minus sine square. And you still have to use double angle identity to really to solve with 0. So regardless, you have to use double angle identity at first or later. So you still have to use one way or another. So the answer is C. Does that make sense?
I didn't use double angle identity.
Okay, so you could use product rule and you get what?
I used identity.
You can put, because it's cosine square minus sine square.
I just mean cosine square is 1 over 1 minus sine.
Oh yes, and I know what you did. Okay, that's fine too. So what he's saying is he got this one, right? Is that what you get at the end? And then you change that to change your sine square or change your cosine square to 1 minus sine square of x minus sine square of x. And that's a 1 minus 2 sine square of x equal to 0. And if you solve for it, it's going to be sine square of x equal to 1 over 2, sine of x equal to plus minus square root 2 over 2. And you would get pi over 4 and 3 pi over 4. Yeah, that's fun too. So that's another way to do it. So there's a product rule there. Anybody have any questions here? It's good?
I have a question.
Yeah.
Since the thing is the restriction is 0 to I, do I have to put the negative sign in front of the
yeah, but you can exclude it at the end. You can exclude all the answer on the bottom because 0 to pi. You can do it and then exclude it afterwards. You're supposed to do it and exclude it afterward because you're going to see the range. You're going to see the domain after everything. You should solve it as it used to be and then look at the domain. Any question about this part? Okay. So this one here, you guys didn't believe it's negative 2 over 3. I'm going to show you it's negative 2 over 3. You should do number line test. Now the second derivative equal to 0. That means inflection point. So you should do negative 2, 0, and 3. And you should do x squared, x plus 2, and x minus 3. Okay, so this one will be positive all the way through. And this one is going to be negative, positive, 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 and negative, 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 positive. So it's positive, negative, negative, positive. Do you see there's only 2 places that sign change, which is at negative 2 and 3? Nathan, did you get it wrong?
Yeah.
Where did you get it wrong? Why did you choose C?
I didn't realize that I needed it.
Oh, you have to do number line tests. Very good that you make that mistakes because yesterday I mentioned you have to do number line tests to see where it is. Okay. Because you cannot not verify the sign change. Is there any questions here?
I have to put the 0 in.
Yes, 0 is going to be included. So the sign changes happen at -2 and 3. Addison, do you understand?
No, I understand. Yeah, I did the same.
So not second derivative equal to 0 is automatic inflection point. Yesterday on the notes, I said possible inflection points. So if it's possible, then you had to go back to verify. Then things maximum and minimum, you had to go back and verify there's a sign change. Is that okay? Okay. What do you guys think of the answer on this one is?
I put C.
Everybody put C? Anybody put a different answer? Matten?
D.
Anybody got D? Okay. You got A? Okay. All the people who choose C, you had the wrong answer because you're not reading what happened here. This is f prime of x graph. It's not f of x. So since it's f prime of x graph, I'm going to show you how to do it. You're going to do a number line test. In this number line test, I'm going to do f double prime of x. What is f double prime of x? Well, that means I'm going to look at a slope. Because if I'm looking at f prime of x, I'm looking at the slope. If I look at f double prime of x, I'm looking at the slope of f prime of x. Does that make sense? So if I look at the slope, it's going to be positive, 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 0. Which is at b, this is going to be positive. After b to d, it's going to be negative. After d is positive. So b and d is only in choices. So D is the only choices.
Yeah, so could you just look at like the change of slope and you need a number line?
Exactly. You can do that. That's only if yes. So change of slope, that's what you're supposed to looking at. But I do a number line just because to verify something. You don't have to do a number line if you can get a correct answer. I don't really see, but you do need to say, okay, they're changing from positive, negative, negative, positive at the two particular points. So you did very good there. And no, you don't have to do number line. Number line is at this point is a kind of a tool for you to see. And this tool is something I'm going to train everybody to do later because later on we're going to spend a lot of time on analyzing the graph. Yes.
But isn't the slope at we're looking, this is the derivative of the actual function. We're supposed to find the inflection point for the original function. So doesn't the slope go from negative to positive? Change the
Yeah, it went from negative to positive and positive negative. They are inflection point.
But when it crosses 0, it goes from the slope changes from negative to positive.
Yeah, that when it crosses 0, when it crosses the x-axis, it just means they went from increasing to decreasing. It's not had nothing to do with concavity. Because it only, so this one, if you look at this f prime of x, this one's negative, 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 positive, 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 positive. Oh, sorry. Negative, 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 positive, positive, negative, negative, positive, positive. Oh, sorry, negative, negative. So that's going to be decreasing, increasing, decreasing. It has nothing to do with inflection points. It's just increasing function going up and come back down. Does not mean inflection point. Natalie?
I was just wondering why it's the second derivative for the test or the line test. That's what I was wondering too, because I thought inflection points were.
As inflection point when the second derivative changes sign, right? Which is when the slope changes. And slope change, the slope of f prime of x, slope, if I'm looking at slope, that means I'm looking at derivative of the prime.
Why aren't all the variables on the number line?
What?
Why aren't all the variables on the number line?
The variable is b and d.
Why only does?
Because that's only things that you have changed the slope. So before b, you have positive slope for the f prime of x.
I'm just kind of confused because I don't know, just because yesterday it was like on the whole, you said before, it's like on the graph, the point of inflection is like when it goes from negative to positive. But
You mean prior homework?
no, like the note
Well, I feel like I'm just confused because I thought the concavity was the
Change in slope.
prime was the change in slope.
Changing slope of the f prime x. Changing slope of f prime x, because slope is the derivative of f prime. So if I take a slope of f prime, that means double derivative. You gotta tell me which example I gave to you that is like that.
This is kind of the basic on inflection is like when it went from negative to positive.
Oh,
Yeah.
you mean like this point here, that it went to negative to
Yeah.
positive?
Yeah.
No, this one is actually a minimum, went from negative to positive. This is actually a minimum in the original functions. It's not the sign change. Now, if I look at the original functions like this is if this is original function, this is the inflection point. The reason why we're not looking at original function, we're looking at the derivative. This is concave down and this part is concave up. So this is the inflection point of original function though.
Yeah, that's what I was getting confused about.
Okay, but this is the original function, is not f prime of x. Does that make sense?
Yeah, that makes sense.
Okay, so this question is kind of messy, so I'm gonna go ahead and I'm gonna do this one. Which answer did you guys get?
I got D.
B is very good. B is really good. Anybody else get B besides Edison? Very awesome. Okay, so I'm gonna go through it. So if I take a point inflection, so I need to find out point inflection first. So I'm gonna take a derivative of this. If I take a derivative of this, is 6x squared minus 6x. And if I take a double derivative of this, is equal to 12x minus 6. I'm gonna take a double derivative equal to 0 because 12x minus 6 is equal to 0. X is equal to 2. Well, x is equal to 1/2. So remember y minus y1 equal to m times x minus x1. So now x1 is 1/2. The problem is you need the m and y1. So let's figure out the m. So if I figure out ben, I'm going to plug in the 1/2 into the prime. So it'd be 6 to the 1/2 squared minus 6 to the 1/2. That's equal to 3 over 2 minus 3, I think. That's negative 3 over 2. So I got negative 3 over 2 now. Does that make sense? And I plug in the original function, so I'm plugging 1/2 into the original function. This is kind of disgusting because 2 times 1/2 to the third minus 3 times 1/2 to the second. So that is going to give you 1/8, so 1/4 minus 3/4. That's equal to negative 2/4, which is equal to negative 1/2. So negative 1/2. So then y plus 1/2 is equal to negative 3 over 2 times x minus 1/2. I'm going to distribute. And I multiply everything by 4. Why do I multiply everything by 4? Because I don't like fraction, because they are in standard form. So that's going to give you 4y plus 2 is equal to negative 6x plus 3. And then 4y plus 6x is equal to 1. So that is the work of B. Any questions here? And I need you to fight all the way through. This is the question I need you to fight all the way through. Good job, Edison and Chef. Anybody else got it right? Anthony, did you got it right? Okay. Madden, very good. So you can fight all the way through. That's the thing. So you gotta be able to be consistent. Like practice like you meant it. This is the question I was talking about. Which choice did you guys pick here? This is the original function now. So this is not an f prime of x. So they would say this is increasing because this is greater than 0. This is the concave up. So which one's increasing concave up? Well, increasing only from here to here. But which one's concave up? B to C, because if you draw tangent lines below, here tangent lines above. Do you see that? So B to C is only choice. 3 only. This is the original function. Now you look at this question the right way, because this is the original function. It's not f prime of x. What do you guys pick on this one? No? Okay, look at the f of x. They are above x-axis. That means f of x is what? Greater than 0, equal to 0, less than 0. Good. So you were to pick, you knock out A already. Is this function decreasing or increasing? So f prime of x is what? Less than 0. So the only one that's less than 0 is B and D. Then f double prime of x is what? Greater than 0, because it's concave out. So the answer should end up to be B. Does that make sense? Do you guys do that? Very good. Taking second derivative. This is the only one you need to do 2 number line.
I mean, I got B. I'll get B for 7.
I'll go ahead and finish this one, and then you can watch the rest of the video. So this one's f prime of x is equal to 12x minus 3x squared. I take out 3x, so that's going to be 4 minus 3, or 4 minus x, sorry. 4 minus x. Now I will do a number line which is at 0 and 4. So 3x is 4 minus x. Now 4 minus x, you got to be careful. This one is going to give you a positive, positive, and negative. This one's negative, positive, positive. So it's going to be negative, positive, negative. So the concave downwards, I'm going to do a second derivative. Second derivative is going to be equal to 12 minus 6x. So x is equal to 2. So 2 here. Now, if it's less 0, it's going to be positive. This one's going to be negative. So only one that's going to be greater than is going to be greater than 4. B is the only answers here.
Do I still get your credit points if I leave early?
Huh? I mean, you let me know. It's okay.
The right answer to
9. Okay, I'm going to go do number 9. Number 9, I think it's B.
On there.
I think it's B. So let's gonna do g prime of x is equal to 30x to the 4th minus 30x squared. So g double prime of x equal to 120x to the 3rd minus 60x. So I'm gonna factor out 60x. That's equal to 2x squared minus 1. And 2x squared minus 1 equal to 0, 2x squared equal to 1, x squared equal to 1/2, x equal to plus minus square root 2 over 2. So you should do negative square root 2 over 2 and a positive square root 2 over 2 and 0. Good. So then that's going to give you 60x, negative, negative, positive, positive. 2x squared minus 1 is going to be positive, negative, negative, positive. So positive, negative, positive, negative. So then concave upward is only from this to this.
Yeah, I forgot the negatives for the 2 over 2.
And I'm gonna do this questions here, f prime x. Okay, but guys can you be quiet? I'm gonna record this last part of the video, please. F double prime of x, because this is concave downward, so you have to take a derivative here. So it'll be 2 times x plus 1 times x minus 2, and then plus x plus 1 squared times 1. So I'm going to factor out x plus 1, and that's going to be 2 times x minus 2 plus x plus 1. And that's equal to x plus 1 times 2x minus 4 plus x plus 1. So that's equal to x plus 1 times 3x minus 4. And that's equal to -1 and 1. So it's going to be x plus 1 and 3x minus 1. This one is going to be negative, no, sorry, negative, positive, and so negative, positive, negative, positive. So concave downward is -1 to 1. And that should be all. I'm gonna record one more question. Shh. So this one I'm gonna take a derivative here. So it's gonna be low d high minus high d low over low. So that's gonna be x squared minus x squared minus 1 minus 2x squared plus 1 over x squared minus 1 squared.
Did you say hi?